Hey, welcome back to Mr. PLs with Precal. This is Unit 2, Topic 1, Lesson 3. We are going to be exploring properties of logarithmic functions and talking about condensing and expanding them. Start off with some just simple basic laws of exponents because it's kind of similar to what we do in laws of exponents. So this is going to be x to the ninth because whenever it's multiplication of two things with the same base, you add the exponents. Dividing things with the same base, you subtract the exponents. When it's a power raised to another power, you multiply the powers. And when it's a negative exponent, you take the reciprocal, so you flip it. Anything to the 0th power is 1. This is also power to a power rule. So keep in mind that both of them have to be raised to that power of 4. So it raises everything on the inside. If there was a coefficient, you would also raise that coefficient to the power of 4 as well. So this becomes x to the 8th and z to the 12th. First thing, okay, there's a couple ways you could do this. You could simplify what's in the parentheses first and then raise it to the 3rd power, or you could raise both of these terms to the 3rd power. So if I simplify what's on the inside, that's subtract of the exponents, so that just becomes x. So this is really x to the 3rd, and x to the 3rd is x to the 3rd. All right, more random practice. So this goes in line with what we had done on the last video. So I'm not going to explain them too much because I want to save some time to this, but I will go through these answers. So this is really 6 to the 2/5. And then when you change it to the reciprocal, it becomes 6 to the negative 2/5. So this is negative 2/5. 10 to the negative 3rd power is this. This is e to the 0th power. This would be 6 to the 0th power. This is 10 log base 10 of 6, so that equals 6, because anytime this is the, I'm sorry, I put a 6 right there. That's common log, so that should be a 10. Anytime you have the exact same base here and here, then the x there is your answer. So this is going to be 1/2. This is going to be 5, because e raised to the 5th power is e to the 5th. This is going to be -2. This is e to the e, so that means x is the answer. We have here reciprocal, so we know it's going to be a negative answer. So this is 7/2, but it becomes flipped, so it becomes -7/2. Yeah, I am rushing through these. Let's see, 10 to the 4th power is what? So that would be 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. And 10 to the negative 3rd power would be what number? So that would be 1 over 10 times 10 is 100, times 10 is 1,000. All right. Okay, so as we get to our basics of condensing, so that's really what this is. So we've been taught how to evaluate each one of these expressions. So that's kind of the way that I'm going to teach it right now. So like 2 to the 3rd power is 8. So this is really a 3. And this side is really a 2 because 2 to the 2nd power is 4. And then 3 plus 2 is 5. So we know the answer to this is 5. But the whole point of this is to be able to match this side to this side. So this is 1 plus this is 2. So this adds up to 3. 3 to the 3rd power is 27 plus 1st power equals 4. This is 2nd power plus 3rd power equals 5. Wait, did I do that wrong? 2nd power, 3, 9, 27. Okay, yes, I did. So that should have been 4 right here. And that's going to make this 6. Okay, now, I did it like this on purpose because there is a shortcut to doing this. So we simplified this to this and this to this, and then combined the two like terms and then got this. If I do the same thing over here, same process I did over there, so 3, 9, 27, 81, and 243, and then 729. So this is really 6. 2, 4, 8, 16, 32. This is 5. 3, 9, 27, 81. This is 4. 2, 4, 8. This is 3. Okay, so they're in order. So clearly you can see that this matches this, this matches this, this matches this, and this matches this. But what's more important here is to notice that We had an 8 and a 4, and that gave us 32. And then we had a 2 and a 4, and that gave us 8. Well, what we should notice is that whenever it's addition of things with the same base, logs with the same base, then you can simply just multiply the two x's by each other. 8 times 4 is 32. 2 times 4 is 8. 27 times 3 is 81, and 9 times 81 is 729. So once again, whenever it's addition of two logs with the same base, then you would multiply the two x's by each other to condense it from 2 logs down to 1 log. Okay, now what if it's subtraction? Well, I'm not going to do it all the way through like I did on the last one, but I am going to show you that whenever it's subtraction, all you have to do is divide the two x's. So 32 divided by 4 is 8. So that should match with this one. And it does, because I can show, so 2, 4, 8, 16, 32. So this is really 5, and this is really 2. 5 minus 2 is 3. And 2 to the third power is 8, so therefore it is a match. 64 divided by 2 is 32. 243 divided by 3 is 81. And 9 divided by 81 is 1/9. So, if it's subtraction, you divide the x's. All right, so now what about these questions? So 2 to the what power is 64? 2, 4, 8, 16, 32, 64. So this equals 6. 3, 9, 27, so that's 3. 4, 16, 64, 256, that's 4. 10 to the what power, so 10, 100, 1,000, 10,000, and 100,000, so that one's 5. Okay, so now over here, I'm going to do kind of the same thing. So this is really 1, but it's being multiplied by a coefficient of 4, so this becomes 4. So log base 10 of 10, so that's 1, so this is 1, and then you multiply it by 5, so that equals 5. This is 1, and then you multiply it by 6, and that equals 6. This is also 1, you multiply it by 3, you get 3. All right, so there's your match, there's your match, there's your match, there's your match. Now, the trick here is that you can always, because 4 to the 4th power is 256, so this is kind of the same thing. So 4 to the 4th power is 256. So you can always take the exponent and then move it in front as a, so if this is 4 to the 4th power, then you can take the 4th power and move it in front. So if this is 10 to the 5th power, then move the 5 to the front. And that's what you can do for logarithmic. So this can be changed, this part right here can be changed to 10 to the 5th power, but then the 5, which is the exponent, becomes the coefficient. So you're literally just moving it to the front as multiplication. As you can clearly see right here. So the exponent can be moved out in front and be placed right here as the exponent. If it's division, that means subtraction. If it's multiplication, that means addition. So those are your product, quotient, and power properties. All right, so which is the properties that we use for expanding and condensing logarithmic functions. So what about this? This is natural log of 2 times y. So we're expanding this. So we want to make this from 1 into 2. So that would be natural log of 2 plus natural log of y, because 2 multiplied by y can be expanded to this. So this is log of x plus log of y, because it's x times y. So this is log of y squared. Now keep in mind the 2 can just be moved out in front. So this becomes 2 times log of y. Same thing goes here, but this is really 100 times x squared. So this is log of 100 plus, because it's multiplication, 2 times log of x. So the exponent got placed out in front, and then it's really 1's 100, 1's x. So this is division, which means it's subtraction. So this is log of 2 minus the numerator minus the denominator. So log of y. Square root of 2. Square root of and square root of. And this one, so we have division, so that's subtraction again. So that's a natural log. So this becomes out in front, the coefficient, 2 times natural log of x minus natural log of y. All right, and which of the following is equivalent to this? So this is, we're going to expand this. Log base 5 of 5, log base 5 of 5. Subtracted log base 5 of x cubed. Now, once again, x cubed, the 3 can go out front like this. And log base 5 of 5, what power of 5 is 5? That'd be 1. So it's really 1 minus 3 times log base 5 of x. And that should be over here. Yes, it is, right there for B. Which of the following is equivalent to this? Okay, so this is division. So this would be log 2 times, because of the exponent, log of y minus log of the square root of x. And that would be, okay, so log square root of x is really x to the 1/2 power, so that 1/2 power can be moved out in front. So there's the answer right there. I forgot about that on a prior question. So condensing a logarithmic expression. Assume, okay, so now we did expansion. Now we're going to be condensing it back down again. So this is log of base 10, because they're both base 10. So this is just natural log. So this is log of 10 divided by 5. And that's really the same thing as log of 2. All right, so this becomes 2 becomes the exponent of the x. So this is natural log of, we're condensing it down to one thing. So this is x squared, times, sorry, not divide, because it's add. So this is x squared y. It's x squared because of the 2 in front of this. Now, that 2, this is a different expression as this. If there was a 2 in front of this expression here, then the 2 would have gone to the y as y squared. A perfect example right here. So this is really log of x cubed minus log of y squared plus log of z. Now, I normally don't break it down like this, but then this is going to be division and then also multiplication by z. So we have here log of x cubed divided by y squared, and then all of that has to be multiplied by z. So like that. All right, so you could have just put the z on top. So really, it's x cubed times z over y squared, like that. All right, condensing a logarithmic expression. All right, so we have this. Let me see, did I miss them? No, I didn't. All right, so this is really log of x to the 4th y. The 4th, keep in mind that this has to be raised to the power of the entire thing. Minus log of y cubed z cubed. All right, since it's subtraction, it's division, so it's log base 10 of x to the 4th, y to the 4th over y to the 3rd, z to the 3rd. Now, the y's can cancel, so you're left with log of x to the 4th over times 1y left over. This one got canceled. That leaves just 1y on top, and z to the 3rd on bottom should be our answer. It was regular log, not natural log. Oh, okay, so I thought we had an answer choice. Which of the following is equivalent to this? All right, so 3 times natural log, this and this. So we have natural log of x cubed plus natural log of z plus or minus natural log of y. Okay, so plus means these two have to be multiplied. So natural log of x cubed times z, all divided by y, should be our answer. X cubed z divided by y. Looks like we have z as our answer. Down to 1 minute left. Expand the following. Let's see. So this expanded, I probably won't get to do all of these. That's going to be, this is 4th root, so that really means 1/4 power. So this is log of x to the 1/4 power being subtracted by 1/4 log of y. Okay, so here the x is to the 4th power, so that's going to be log of 1,000 plus log of 4 times log of x. This one, so we've got log base 2 of, so this is a negative, so log base 2 of x squared, so the negative 2 can be brought out in front of x, just like that. Then